Hi everyone, my name is Ayush Acharya and today I will be presenting on one of the most fundamental and widely used concepts in computer science and data management, which is relational database. Over the next 10 to 15 minutes, I'll walk you through everything from very basics of what a relational database is to all the way to the real world SQL examples, normalization, transactions, and the most popular database systems used in industry today. So let's get started. Here's a quick overview of what we'll be covering today. We'll begin by understanding what a relational database actually is. From there, we'll explore the core concepts of table, rows, columns, keys, and relation. Then we'll dive into SQL, covering CRUD operations, joins, normalization. There's a lot to cover, so let's just jump right into it. So, what exactly is a relational database? A relational database or RDB is a system that organizes data into structured tables made up of rows and columns. These tables are also called relations, which is where the name relational came from. The key idea is that data is stored in a well organized way and we interact it using a language called SQL or structure, which is structured query language. There are three fundamental characteristics of a relational database. First, they are structured, which means data follows a defined schema, meaning each table has a specific set of columns with defined data types. Second, they are relational. Tables can be connected to each other through shared keys, allowing related data to be linked without duplication. We'll be studying this further in the next slide. And in third, they are SQL powered, which makes it easier to operate because all the operations on the data, whether reading, inserting, updating, or deleting, are done using SQL. Think of it like a very powerful, organized set of spreadsheets that can talk to each other. It was founded by E.F. Codd in 1970, as you can see in this slide. It's been more than 50 years since it was been founded, and it is still being used today. So it is quite important to learn about the relational database. So to learn about relational database, we have to first learn about some core concepts of tables, rows, and columns. As you can see in this slide, table is a named collection of data about one entity. Example, customer, product, employee ID, work, etc. And each table has rows and columns. Rows are also called records or tuples, each representing a single item or entity. And columns are also called fields or attributes representing the properties of that entity. For example, as you can see in this table at the right called employee table, it has columns like employee ID, first name, department, salary, and every row in the table would represent one real employee. What makes relational database powerful is the ability to link these tables together using a concept called keys, which will study in the next slide. And we have cell and schema. A cell is the intersection of a row and column. It holds one value. Schema is a blueprint of a table, column names, data types, and constraints. So, what are primary and foreign keys? A primary key is a unique identifier for each row in a table. No two rows can have the same primary key. Think of it like your national identity card number. It is only unique to you. No other person can have the same citizenship number as you have. So, the next one is foreign key. It is a column in one table that refers to the primary key of another table. This is how the relationships are formed between tables. For example, an employee table has a primary key, let's say employee ID, And we have another table called work table, which has a column employee ID as a foreign key. This tells us that this employee belongs to this work. The two tables are now linked. And the next one is the types of relationship. We have mainly three types of relationship. First one is one-to-one. For example, an employee and employee profile. Each employee can only have one employee profile, so they have one-to-one relationship. Second one is one-to-many. For example, customers and orders. Each customers can have as much as orders as he or she likes, so they have one-to-many relationship. The third one is many-to-many. For example, students and courses. Every students can have different courses, so they have many-to-many relationship. Next, we're going to learn about data integrity and constraints. So what are data integrity actually means? It means maintaining the accuracy, consistency, and reliability of data stored in a database. It ensures that the data is correct, valid, and not duplicated or corrupted. For example, a customer ID should not be empty, or an order should always belong to a valid customer. Next one is constraints. Constraints are rules applied to database columns to enforce data integrity and prevent invalid data entry. Primary key uniquely identifies each record in a table. These are some examples of constraints: not null, primary key, check, unique, foreign key, and default. Primary key uniquely identifies each record in a table. Foreign key creates relationship between tables. Not null ensures a column cannot have empty values, and unique constraint prevents duplicate values. And check ensures values satisfy a condition. And default assigns a value automatically if no value is provided. These are some constraints. So let's move on to the next slide. Let's take an example of an online bookstore. For example, for simplicity, let's take four tables for online bookstores: customers, books, orders, and order items. Now, from these tables, we can answer some few questions. For example, what did Priya order? Let's say in the order item, we have the order ID and book ID is 501 and 101 respectively. From this, we can see in the book table, the one which has the 101 book ID is the book The Alchemist. So we can see that uh, Priya buys a copy of Alchemist, and we can also know some information from this table. As you can see, the Alchemist price is 12.99, and the author and the next, and from these tables we can also know what is the total revenue per book and which customer bought books by the author James Clear. All the informations can be seen from these tables. Next one is SQL fundamentals, select and where. These are some queries, uh, basic queries which we need to learn uh, for relational database using an SQL. First one is select. It just select asterisk from customers. It means select the customer table. So next one is select. To select the specific column, we use select customer ID and name, email from customers. And to filter rows with where, we select order ID, or to where specifies what we need to select. So in the example number 3, we can see that select order ID, order date from orders where customer ID equals to 1 and order date is greater than or equal to 2024-101. So so the next one is joins. It is used to connect tables. For example, we have one table called employee and another table called work. To join these tables, we use the command we have. From this example, you can see that from customer C, we have inner join orders and orders O on C customer ID. These are some queries which you can also try on SQL bench press. The next one is aggregation and group by. We can see the total revenue per book. To see the total revenue per book, first we need to select the book title and we need to add the total sum, the total quantity of the book and the price per unit. Let's say we buy Priya buys five book of which each book costs 12.99. So which we multiply 5 by 12.99 to get the total sum of, and these we take this data from total items, and to get the entities from to get the attributes of book, we join the book table to by using the join command, as you can see. So these are some queries to join multiple tables. Next one is normalization. It is the process of organizing tables to eliminate data redundancy and ensure logical data dependence. We use mainly three types of normalization. First one is 1NF or first normal form. From this slide you can see each first normal form is where it has the three qualities. First one is each column hold atomic or individual values, no repeating groups or arrays in the column, and each row is unique. So first 1NF and second one is 2NF or second normal form. For second normal form we have to meet all the requirements from 1NF, and then the other requirements are every non-key column depends on the entire primary key. So each time we level up from 1NF to 2NF, the data redundancy is decreased and it becomes more efficient. And 3NF must have all the requirements from 2NF and no transitive dependency from key columns. Next one is ACID properties. The relational database has four main properties, which is why we use the relational database. First one is atomicity and ACID. First, A stands for atomicity, C for consistency, I for isolation, and D for durability. And some popular RDBMS platforms are MySQL, PostgreSQL, SQL Server, Oracle, or SQLite. So, MySQL and PostgreSQL are open source and widely used in web applications. Facebook, for example, many popular websites like Facebook, Netflix, Uber, Spotify uses MySQL, and we have Oracle database. Oracle database is also the backbone of many large corporations like Amazon, eBay, JP Morgan Chase, and the Industrial and Commercial Bank of China, Adobe, and LinkedIn. And SQLite is very lightweight and used in mobile apps and browsers. Next one is RDBMS versus NoSQL. When to choose what? So, as you can see from this slide, the data structure of the relational database is fixed schema, columns defined upfront, and NoSQL is a flexible schema. And second point is query language. And relational database has standardized SQL across all vendors, and NoSQL has vendor-specific APIs or query language. And we have the many differences like in transactions, scalability, relationships. The transactions for relational database is full ACID guarantees, as we have already learned from the previous slide, the meaning of ACID. And in NoSQL, often eventually consistency based model. And about scalability, the relational database is vertical scale up, which means it has certain limits. It has a hardware limit, whereas in NoSQL it has horizontal or distributed clusters. Which is why in today's world we use many different types of database like graph database to ensure such uh, to to have no vertical or hardware limits. Next one is relationship. It has a native joins across table, and in NoSQL denormalized joins must be in application code. And each one has its own pros and cons. So relational database or RDBMS is mainly best for finance, ERP, e-commerce, healthcare, whereas NoSQL is mainly best for IoT, Internet of Things, social media, and real-time catalogs, etc. So what we learn from today's presentation. To wrap up, a relational database is a structured system for storing data in interlinked table queries using SQL and designed to ensure data is accurate, consistent, and retrievable. Through our bookstore example, we saw how four simple tables, customer, books, order, and order items, can answer complex real-world questions about purchasing behaviors, revenues, and customer preference. So next time you log into your bank app, place an online order, or look up to a hospital appointment, somewhere behind the scene, a relational database is making sure the right data reaches the right person at the right time. Thank you.